So the fan, if it's an older boiler, you'll have an air pressure switch. An air pressure switch is basically a flow switch for a fan. Same thing, PCB sending voltage into that air pressure switch. When the fan spins, it sends it back to tell the PCB that the fan's spinning. That's how the PCB knows the fan's spinning. Air pressure switch tells it. On a more modern boiler, the PCB is looking for the fan speed. What's up guys, happy Sunday. Thanks for tuning in to my latest video, The Life of a Jobbing Plumber. If you're watching this and you don't subscribe, please click the subscribe button just to be nice. So this weekend's video, various jobs from my working week, including some boiler fault finding, and I've gone a bit more into detail with that, with the boiler sequence of operation. So basically how I approach a boiler fault, the steps I take in my head, which I hope you'll find interesting and hopefully useful. What's up guys, 60-second fault finding on this Ideal Mini with no heating or hot water. First thing I've done, check that I've got a demand on. So my programmer there calling for central heating, boiler's doing nothing. Even when we open the hot tap, although the flow switch on the boiler looks like it's activated with the red neon there, the boiler's doing nothing. The first thing I'll check on a boiler like this is the primary flow switch or the central heating flow switch. So we've got a micro switch there that's attached onto the hydraulic block. In normal operation, when you call for demand, heating or hot water, the pump spins. Once the pump spins, this pin pops out, activates the micro switch, tells the PCB it's safe to carry on with the ignition sequence. So the pump's not spinning, but I still need to prove if it's a pump fault or a PCB fault. So remove the plug from the pump, checking for voltage, and we can see there that the PCB is sending 240 volts to the pump, so we need a new pump. And just to prove it, activate the micro switch manually and the boiler fires up. Right guys, going off that 60-second fault finding video, I thought I'd run with you sequence of operation, basically what I do in my head when I'm fault finding on a boiler. So I've drawn this diagram. Now I'm going to keep it very basic, but if you enjoy this and you want me to go into it in more detail in a future video, we can do that. So we're going to use that Ideal Mini that I've just shown you as an example. I attended, no heating or no hot water. So the first thing I do is check if I've got a demand. So combi boiler, either open a tap or select central heating on, turn your room stat up, whatever, get a demand. Once you're satisfied that you've got a demand, we start from the PCB, and everything comes from the PCB on this. It all links back to the PCB. And basically, we're following the voltage that the PCB sends out to different component parts, or the voltage it gets back. So we start at the PCB. Once we know we've got our demand, the PCB will send 240 volts to the pump, and then the pump will either spin if it's working, or it won't spin if there's a fault. If it doesn't spin, then we need to check, is the PCB sending the 240 volts there? If it is, the PCB is doing its job, so it must be the pump that's faulty. If the pump does spin, it activates the flow switch, and the flow switch is what tells the PCB that the pump's spinning and it can move on to the next thing in the sequence. The way this works, we've got the PCB sending voltage into the flow switch. When the pump starts spinning, it connects it and sends it back to the PCB. Once the PCB gets that signal back, yep, the pump's spinning, I know because the flow switch has told me it is, then we move on. If the pump was spinning but the flow switch failed, so on the hydraulic block the pin wasn't coming out to push that micro switch to send the live back, then we know PCB sending 240, pump spinning, but we're not moving on to the next thing because the flow switch isn't doing its job. If the flow switch is okay, then PCB sends 240 volts to the fan and the fan should start spinning. If the fan doesn't start spinning, have we got 240 volts to it? Yes, fan's faulty. Have we got 240 volts to it? No, PCB's faulty. See what we do, we rule different things out in the sequence. So the fan, if it's an older boiler, you'll have an air pressure switch. An air pressure switch is basically a flow switch for a fan. Same thing, PCB sending voltage into that air pressure switch. When the fan spins, it sends it back to tell the PCB that the fan's spinning. That's how the PCB knows the fan's spinning. Air pressure switch tells it. On a more modern boiler, the PCB is looking for the fan speed. If this is all good, we then move on to the sequence of ignition. So the gas valve gets 240 volts from the PCB. Then the gas valve opens, lets the gas through to the burner. The igniter unit gets 240 volts from the PCB, ignites the gas. Once the gas is lit, the flame sensor, flame rectification, basically changes the signal to DC back to the PCB. The PCB is looking for the DC signal from the flame rectification probe to tell it that the flame's lit, and then the boiler fires up. So looking at the sequence of ignition between the gas valve, ignition and rectification, if we've got 240 volts from the PCB to the gas valve should open and let the gas through to the burner. If the gas valve doesn't let the gas through and we've got gas to it and we've got 240 volts to it, the gas valve's faulty. If we've not got 240 volts to the gas valve, PCB's faulty. If the gas valve opens, lets the gas through, the igniter doesn't light it, either because it's not sparking, ignition unit faulty, or the spark isn't close enough together to give us the correct heat, then ignition electrodes are faulty. If the gas lights and then goes out after a few seconds, we're not getting flame rectification. So is there a fault on the lead or the flame sensor or the flame picture? So we use these things, sequences, the gas open, lights, does it stay lit? And you can rule one or the other out. Once that's all complete, as I said before, your boiler will stay lit. And then going into more detail, there's other things from the PCB like temperature sensors, the diverter valve, does it send it to the heating or the hot water? But basically, that's the sequence I follow in my head when I'm fault finding. And you can go into more depth. All the information you need, like the fan speed, the thermistor resistance, the resistance in this, the lead for the flame rectification, is all in your manufacturer's instructions in the back of the manual, or they'll give you when you call technical for technical advice. I hope that's made sense. It's made sense in my head. That's how I do it. If you do want me to do another video like this, going into a bit more detail, let me know in the comments and we can sort something out. So in last week's video, or the week before, I found a bit of gravel in a pump and I asked people what was the weirdest thing they found inside a pipe, and it reminded me of when I found this really long piece of wood inside a 22mm pipe. Don't know how it got in there, but it was proper long and it had been in there a while because it was like mush. So a couple of weeks ago I capped off this gas hob because there was a gas escape on it, and I'm back now to fit the new one. So I just thought I'd do a step-by-step how I replace a gas hob. So remove the oven from underneath, unplug the hob, that came through that hole and there's a plug in the cupboard next to it. Obviously the gas pipe's already been disconnected and capped, so we've just got these brackets left to remove. And then the hob will either be on some foam pad or in this case stuck down with, I don't know, it's like Play-Doh, blue tack stuff, horrible stuff. So you need to remove the hob. Once the hob's out, clean all the gunk, Play-Doh, whatever off the edge, get it as clean as possible. And then you can offer the new hob in to see if you've got to cut any of the worktop out. It's at this point that your customer is going to joke, oh, I don't remember ordering a blue one, and you can do that fake laugh that we all love to do. Unfortunately for me, I've got to take about 10mm off. Only one edge though, so it's not the worst in the world and it's nice and easy to get to. This is probably one of the only jobs I'll ever need a jigsaw for, but you see I just had to take 10mm off the front edge there. Now it's sitting nice and flat. So while we've got it offered in, I'll check if the gas pipe lines up, if I need to make any alterations. I've got pretty lucky with this one. It's almost exactly where I need it to be. Then my step-toe gene kicks in and reuse the old flex because there's a plug on it. The new one doesn't come supplied with a plug, so I'll just swap them out. I'll be able to use that black flex on another job, so I'll just keep it on the van. Then we're going to put the foam seal round. I always start this from the back edge because you don't want that join sitting at the front where you can see it. Obviously we cleaned this before we started, so it's now dry enough to stick on. Then we offer it in, and while it's offered in, before we put the brackets on, we connect the gas because you don't want to fix it down and then have to take it out again to work on the gas. Again, before it's fixed, I'll just turn the gas on and give it a quick spray just to give me an idea if the pipe works good. Once I'm happy with the gas, I'll fix the hob into the worktop using these brackets. Can't stand these things. So awkward to use and you'll end up dropping them down the back of the cupboard. Then you've got the battle of taking this blue film off, leaves a nice stain on it because for some reason they don't cover the whole thing. And you can have another joke with your customer about, oh, it's not blue after all. Then I'll do a tightness test on the gas supply. But I don't know why I do this, but I light the hob, and while it's running, I'll check again with my leak detector spray. It's just something I've always done. I don't know why I do it. And then we're done. Right guys, this call out was because the boiler had started making a noise that it hadn't done before and the customer was worried. Basically the noise when the boiler was firing up, a kind of vroom, like a rushing sound. And that is caused by the delay of the gas lighting, and that can be down to the ignition electrodes. So when I take them out, I'll show you, there's a distance between the two, and that's where the sparks across. And because they're in heat all the time, they can bend out of shape. Now they should be about 4mm distance between there and there. And as a rule, we say it's about the distance of a pound coin. New pound coins are slightly thinner than the old pound coins, but just to give you an idea. Now I'm going to show you the spark. We're going to do this with the gas turned off. That's very important. So you can see the spark jumps across between the two. Now the closer they are together, the hotter the spark. The further they are away, the cooler the spark. It either won't be enough to light the gas, or it'll be so far away that it won't spark. You can see here on the new one how close it should be. It's about the distance of that pound coin. And then just to give you the comparison with the new electrode in, you can see the spark there. It's a lot tighter, so that spark will be hotter. Now this one isn't the worst one you're ever going to see. Sometimes they'll bend right over here. I've seen them when they're sort of this far apart and they still work. But obviously it's not the correct distance. Now you can try and bend this back. I've done them before when they're cold and they generally snap, normally down here. So the tip is to heat them up. And then we should be able to bend it without risking it breaking. As well as bending away from each other, it can also bend away from the burner, and there is a set distance it has to be. So when you're servicing it, you need to check this. So the distance between the ignition electrodes and the burner should be 10mm plus or minus 1mm. And then the flame rectification or the sensing electrode needs to be 7.5mm plus or minus 1mm. All this information is available in your instruction manual. Just go to the fault finding section on the back seat, and you'll see there it gives you all those distances. The fault finding sections in boiler manuals are great. If you don't spend time looking at them like I do, just have a look through. There's so much information in there. Once we've checked those distances and fitted the new electrodes or bent the old one back into shape, it should light first time. And a little tip for you, if you've serviced one of these back seats and you put it all back together and it's not lighting, just check you've not left this rubber hose off. The boiler won't light unless that's attached. Right, if you've been living under a rock, you might not know what this is, but it's a Milwaukee auto pipe cutter. And when I first got it, I absolutely loved it, used it for everything. There's the model, C12PC. And yeah, used it for everything, especially big jobs when you're cutting a lot of copper, when you're ripping out, it's brilliant. But then I tried to cut a shower, a stainless steel shower riser pole with it. So now what happens is when I try and cut the copper, it just turns and turns and turns. It's not cutting it, so I've blunted the wheel. And literally the only thing that stopped me from getting a new pack of wheels, cutting blades, is I'm a lazy bastard. And I bought these so I could fix it for a video for YouTube, and then I'll use it again. But I just can't explain it. It's like, you know when you do a job and let's say you need, I don't know, a 10mm spanner, but you try and do it with your little pair of grips, you try and do it with your, I don't know, say you've got a pair of pliers in your kit bag, you'll try everything, you'll waste 10-15 minutes just trying to do it with what you've got in front of you, rather than just go to the van and get the 10mm spanner. I can't explain it. So what I'm going to do now is going to do a video. We're going to put the new wheels in. I bought these online. I paid 20 quid. Apparently you can buy them for about 6 quid for the pair. Just shop around for them. So it's dead easy. Just going to flip it over. I'll hold it close to the camera. You see, just there, got a little circlip. So I'm going to ping that off and try not to lose it. I'm looking at this through the... Let me just move it slightly. There, that's better. See that circlip there? So I'm just going to ping that out, try not to lose it. Right, there we go. I've wedged, where's it gone? Literally landed up there. Okay, and then all you do is push this pin, pop it back up. That pin there, push it out. You see it's come out there? So once you've got the pin out, the wheel will just pull out of that gap. That's the gap it sits in. So that's our old one. And then the new one, pop it back in there like that, and just push the pin back up through the middle of it. You might have to just wiggle it around a little bit. See there, I've got my wheel, my new cutting wheel in there, and then I've just pushed that pin up. So what I need to do now is, while I'm holding the pin up, pop my little clip back on and just push it on. It's spring loaded, the jaws, so obviously they open up to do 15, 22 and 28mm copper, so it will push back. But once we're on, nearly there. I think that's got it. It's actually easier to do it this from spinning it round. If I was going to do that again, rather than do it at the reset position, try and stop it so it's a bit more out in the open like that, because then it doesn't push back. So now, when we try and cut the copper, it should cut in. It does give a nice clean cut. And then the other thing I'm going to do is give it, because it's a bit dirty, not used it for a while, just give it a bit of a clean. So just got some cleaner here. While it's spinning around, I'm just going to spray it. Both sides. I've got a steel brush. That's it, easy as that. If you want to know where to get one of these from, I'll drop a link into the Power Tool Make website. Does some great prices on Milwaukee gear. If you remember the live video I did on Monday, this is that job, full central heating, big rip out, and that's when this becomes really handy, because I've got a lot of copper to strip out of this job. So 28mm primary, no problem. This is going to be a pretty boring video because you're just going to be watching me cut pipe, but that's the 28mm cut. Reset it, move on to 22mm, no adjustment, just reset the cutter and pop it on. Just cut that, reset it, and then 15mm, no adjustment, just bang it on. Really difficult sometimes to get it in close to the wall because you need a bit of a distance around it, and it will jam up if you force it in to too tight a spot, but it is a great bit of kit. If you've not got one, I'd highly recommend it. Have you ever been on a training course and not learned anything? For example, I've been on loads, You go on the course, you listen to the lecturer or the course tutor talk about the subject, maybe show you a few screens. You sat there in a big group, and then it will say something and say, right, did everyone get that? And you're all sat there, and I guarantee a few of you are thinking, what the hell has he just said? I ain't got a clue what he's talking about. But you won't be the guy that wants to put his hand up and say, I didn't get it. So you'll just sit there and you'll pretend that you got it, and then they'll give you a little test, easy enough, or you've got open book answers so you can just fill it in. You get your certificate to say you've passed the course, and then you go home being none the wiser. You don't actually learn anything. And after you've left college, once you start working, you're probably only training you're going to do is when you do your gas reassessments, or maybe you do your unvented hot water, stuff like that. Me personally, I think training is great. Learning new things, understanding how things work. I mean, we can all fit a boiler, we can all fit a central heating system, but do you really understand how it works? And understanding how something works is really important if you're fault finding on it. But also, if you're running your own business, understanding how something works means that you can design your own systems, not just put in a basic central heating system, but really understand what you're doing, what you're fitting into that property, and getting the most out of it, the most efficiency, the best performance out of it. And training that you can do to increase the services you offer. Like at the minute, I'm domestic gas, I do central heating systems, combi swaps, stuff like that. But I could go on a training course and learn how to do air source, ground source heat pumps, solar, all kinds of renewables that are out there, and then offer that as a service that my company does to earn more money. At the end of the day, that's why we do it. But there's no point going on a course to learn how to do air source heat pumps, getting the certificate, ticking a few boxes to say, yeah, I'm qualified, and then getting out on site and be like, where the hell do I start? Because I've got the qualification, but I don't really know what I'm doing. So I'm really excited about this new course. You might have heard of it if you're on Facebook. It's called Heat Geek. And it's basically a course to learn about how everything works, from the most basic things to the most complicated things. And what the guy's done, his name's Adam, is he's took all the information that you might have to sift through to get the actual useful stuff, and it would put your normal guy off doing this kind of thing, thinking that's too complicated, it's too involved for me. He's broke it down into a simple way that you can understand, and made this course that, rather than just do it, pass the exam and get the qualification but not really understand what you've done, he's broke it down and you can do it in your own time. So you watch a video, you listen to what he's got to say, and then if you didn't get it, you watch it again. And then if you still don't get it, you go into the group chat with everyone else that's doing it, and you're encouraged to ask questions. You're not looked down on. People don't take the piss out of you if you don't understand it or you've got an answer wrong. They actually want to help you. And because they want to help you and you feel like you're comfortable to ask the questions, you're then going to learn, and you're really going to learn. You're going to take it in. And the exams are designed so that you don't just pass the exam, get your certificate. You can only pass the exam if you really understand it. They make them difficult so that you can't just pass it without actually knowing what you're talking about. So I'm really excited about doing this. Hopefully I'm going to learn a lot, and hopefully the stuff that I learn off the course, I'll be able to pass on to you guys if they let me. So I got my course pack through this week. I'm going to show you that now. So here's my workbook folder. Now, you don't have to buy the folder. Everything that's in here, all the different modules, everything you need, you can print off in a PDF and make your own folder up. But I just went for the folder. So let's get that out of the way. So basically, we watch for each module. So module 1, what is energy? You watch a video. This video was, I think, about 6 minutes long. Once you've watched it, if you think you understand it, you can take the exam. And it's going to be a difficult exam to make sure that you took in everything that you learnt from the video. You didn't just watch it and didn't take it all in. But the beauty of it is you can do it in your own time. So if you watch it and you don't understand it, watch it again. If you then don't understand it, you go in the Facebook group and ask questions, and that's what they want you to do. Anything you don't understand, go in the group and then someone will explain it to you, maybe in a way that breaks it down a little bit further, explains it in a way that you understand. I think that's brilliant, because one guy, the guy who does this, Adam, is great, but the way he says it, it might not be the way that works for you. So someone in the Facebook group might say, oh, hang on, yeah, just think of it like this. And then you get it and you absorb it and you understand it. And then you take the exam. If you pass it, all well and good. If you get it wrong, it tells you which ones you got wrong. So then you can make notes, go over that again, get in the Facebook group and say, oh, I got this one wrong. Why did I think it was this and not this? And someone else might have had that experience. I think it's great. So I'm going to go through this. There's 2 parts of the course. This is the awakening, and then there's mastery after that. One of the other things I liked about it is after I watched the video, it gave me some additional resources, so you can go a bit further if you want to, if it's interested you or you want to learn a bit more. That one was a podcast, that was good. And then this YouTube video, which explained the system of units.
Meter for length, kilogram for mass.
It reminded me of like a science lesson at school, and I've not done anything like this training wise since I was at school, so I think I'm going to really enjoy it. So that's the Heat Geek course that I'm going to be doing. Comes in 2 parts. I'm going to start the first part this week. Obviously I'll keep you updated with how I get on with it, but if it's something that you're interested in, I'll leave the link to that course in the description of this video. And also I've got a discount code if you do want to do the course. I think it's PB5, but I'll put that on the description as well. If you use that, when you book the course, you'll get some money off.
Yo, what's up? My name's Gaz. I'm from Fluorite Southwest, and I fucked up. About 3 or 4 years ago, we were installing central heating packs. We were doing a job, and I said to the lads, oh, while you're bringing the gear in, I'll start getting the floorboards up upstairs, ready for running the pipe. So I went up. I was at the back of the property, wasn't expecting there to be anything under the floor. Got the circular saw, pulled the cart back, got the circular saw out, started cutting into the floor, and I hit a cold water main 22mm pipe, and the water was pissing everywhere, squirting all in my face. I was shouting to the lads, help, help, turn the water off, turn the water off. Anyway, they come back in, can't find the stop tap, can't find the stop tap. Eventually I found the stop tap in the kitchen, turned it off after about 10 minutes probably of the water running. I'm not joking, I walked through the living room and it looked like a scene out of the rainforest. It was just water pissing out of the ceiling everywhere, carpet was soaking like a little pond. And a lady just pulled up, she pulled up on the driveway. So I just went out to her, I said, oh listen, we've had a little bit of a leak, so just give it 10 minutes and then I'll come and give you a shout when it's safe to come in. She's like, yeah, no worries. We were in there, we had all the wet backs out, trying to suck up all the water and get it all dry. But yeah, moral of the story is, make sure you know where the water runs, and that you just don't go cracking on with a circular saw through the floorboards without knowing what's underneath.